Today's video will explain how chemists can apply the equilibrium expression and ice tables to determine the concentration of acids at equilibrium. Before we can learn how to do the calculations, it is important to have a conceptual understanding of why acids of the same concentration can have different concentrations of hydronium ions. Different acids can react with water to varying degrees. Strong acids react 100% with water. Weak acids react less than 100% with water. The more the acids react with water, the higher the concentration of hydronium ions will be in solution. Compare the outcomes of reacting these two different types of acids with water. HCl is a strong acid, so 100% of the acid will be converted to hydronium ions. Acetic acid is far less reactive, and so only 1.7% is converted. When we are looking at balanced reactions for acids, we will use an acid ionization constant instead of the equilibrium constant. These values are in your data booklet on the acid-base table. If you look at the top 6 acids on your acid-base table, you will notice that the Ka value listed is very large. This is because these are quantitative reactions, and so we can expect all of the acid to react with water to form hydronium ions. Any other acid is considered to be a weak acid. Ka values are used in chemistry because their values are valid over a wide range of concentrations. One of the types of questions that you will do with acids is you may be asked to calculate the acid ionization constant with concentration and pH values. When given concentrations, they will correspond to the initial value for the acid. Notice how the initial values for the two products are 0 and close to 0. The 0 is because there is not any of the conjugate base in the water initially. The almost 0 for hydronium ions is because there is a small amount of those ions in water. The change for each of these entities is x because the coefficients in front of each entity in the balanced equation is 1. In this question, we are given the pH of the solution at equilibrium. We can use this value to calculate the concentration of hydronium ions. Once we know that value, we can write the expression for the acid ionization constant. Revisiting the ice table, you should be able to solve for all of the values at equilibrium now. Start with the concentration of hydronium ions and work your way through the table systematically. It is helpful to remember that the concentration of each of the products is the same because there is a 1-to-1 ratio. Once all of the values are determined, we can solve for the acid ionization constant. To find the percent ionization, we must divide the concentration of hydronium ions by the initial concentration of the acid. In this type of question, you are given an acid with a known value for the acid ionization constant and are asked to determine what the pH would be at equilibrium. Although the question doesn't state the Ka value, we can look it up on the acid-base table in our data booklet. Start by setting up an ice table. The concentration of the acid is the initial concentration in the ice table, and the products are 0 or close to 0 again. Now pay attention to this step very closely because it's going to make your life much easier. There's an approximation that is allowed in these calculations under special circumstances. If we divide the concentration by the Ka value and get a number that is greater than 1,000, the amount that ionizes is not significant in comparison to the initial concentration of the acid. In this example, the value is over 1,000, so the 0.25 minus x can be simplified to 0.25. This means no quadratic formula. With this approximation, the solution for the concentration of hydronium ions is much simpler to calculate. With the value of the hydronium ion concentration, we can calculate the pH by taking the negative log of the concentration. Please note that none of the acid ionization questions that you will be given will require that you use the quadratic formula. Be sure to test your values to see if you can make the approximation. Please complete the December 14th quiz.